For the following problem, we want to sketch h of x equals negative times the quantity of x squared minus 1 times x plus 2 to the third using x-intercepts, y-intercept, multiplicities, and the lead term. To start this off, we need to factor this entire function to find all of our zeros or x-intercepts. So we start with h of x equals this negative we have on the outside, and now we'll start with x squared minus 1. That's the only term that's going to factor in this problem, and that's a difference of squares. So we get the square root of the first term, which is x, minus the square root of the second term, which is 1, times the square root of the first term plus the square root of the second term. So x minus 1 times x plus 1. Times x plus 2 quantity cubed is already completely factored. And now that we have this, we can set each of these factors equal to 0 to find our x-intercepts. So we'll make a note of this. Our x-intercepts will be x minus 1 equals 0, x plus 1 equals 0, and finally, x plus 2 equals 0. And when we solve each one of these, we're left with x equals positive 1, x equals negative 1, and x equals negative 2. When we add 1 to each side, subtract 1 from each side, and subtract 2 from each side. So these values are where we hit the x-axis on our graph. And from here, we can use the multiplicities to decide what happens at each of these x-intercepts. So for instance, the exponent of x equals 1, meaning if you go back to its factor, x minus 1, it has an exponent of 1, which means its multiplicity is 1. For x equals negative 1, its factor was x plus 1, and again, its exponent is 1, so it has a multiplicity of 1. And finally, x equals negative 2's factor was x plus 2, it has a multiplicity of 3. So what does each of these mean? Well, let's just make a quick note here. For the multiplicity of 1, that means the graph passes through this x-intercept. Again, for a multiplicity of 1, it means the graph passes through. And then finally, for a multiplicity of 3, it means that the graph passes through the x-intercept with a curve. So whenever you see a multiplicity of an odd multiplicity, it's going to pass through, and if that multiplicity is greater than 1, so if it's 3, 5, 7, so on, it will pass through with a curve to it. If it's an even multiplicity, then it will always just bounce back. It'll look like a parabola. Okay, so going back to this, we now have the x-intercepts, the multiplicity. We can now decide the y-intercept, and the y-intercept occurs when we find h of 0. H of 0 just means we're going to plug in 0 for all of our x's and simplify. Which gives us negative times negative 1 times positive 1 times 2 cubed when we simplify all of our terms, which leaves us with negative negative 8 or positive 8 or just 8. So our y-intercept is the point 0, 8. And this gives us a rough idea of where to place one extra point on our graph. And now finally from here our last step is to find the lead term. And the lead term is going to be when we take all of our largest exponents in each of our factors and we multiply them together. So we start with this coefficient on the outside of our factorization, this negative. We're going to multiply that negative by this x because it's our largest term. So negative times x times, again, our largest term is x in this case. And then one more time we have this x, but notice its exponent is 3. So it's x to the third power is our lead term there. So when we multiply all of our lead terms together, or all of our largest exponents together, we get negative times x times x times x cubed, or negative x to the 5th power is the lead term of this polynomial. If that process confuses you, multiplying the largest exponents together, just multiply the entire thing out. It'll take a little bit of extra time, but you'll end up getting this negative x to the 5th as your lead term anyway. And now with all of this, what does this tell us? Well, we know whenever your exponent of your lead term is odd, that means your graph has arrows pointing in different directions, meaning the graph will either look like this or it will look like this. And the way we decide which of those we want is by whether the lead term is positive or negative. Since it's negative, it's going to be this one. We want the ends that start in the top left and go to the bottom right. Okay, so with all of this, we can finally graph. So we'll start by making our sketch by putting down the x-intercepts first. So I'm going to put some tick marks on the graph here from -4 to +4, and then I'm going to go all the way up to about 10 on the y-axis because we need to plot the point 0, 8 at some point. So I'm going to make my y-axis tick marks by 2's for sake of room. So from 10 and -10. Now we'll list off our x-intercepts, which occurred at x equals 1, at x equals -1, and x equals -2. And we said our graph starts in the top left and goes to the bottom right. So I'm going to make a little arrow here in the top left and another arrow in the bottom right. And now from here, I'm going to put down the y-intercept, which is the point 0, 8, which is right here in my graph. And now all we need is the multiplicities. So remember, as we approach x equals -2, that's our furthest one to the left, we're going to pass through it with a curve. So we're going to approach it, and then it's going to look like the graph of x cubed, how it goes like a curve through it. Oh, I didn't mean to click that. So once we do that, eventually we are going to have to come back to this point. We have to hit this point on our graph at some time. So the graph is going to look like this, and then it's going to come back like a turning point or a relative minimum. And the graph will come to this x-intercept, and notice at x equals -1 it passes through. So it's going to come through just like a straight line. And when it does, it's going to have to pass through this y-intercept and then come back down through this x-intercept, meaning the graph is going to look something like this. And when it hits this x-intercept, again, at x equals 1, the multiplicity was 1, so it passes through again. And it passes through like a straight line, which means the graph looks like this. And I'll go ahead and blur out this arrow to avoid confusion. So our final graph looks something like this. This is just a sketch though. If you actually draw this out on a calculator, so you actually plug it into your calculator, you would actually get something that looks more like this.